And welcome back to your regularly scheduled programming. I am John the Coder, and tonight we're starting Chapter 7. As a quick review, we are going through our Python Crash Course, second edition. PDF is in the description. And last time we reviewed loops. Really, it was kind of all together. Chapters 5, 6, and we're about to start 7. So with those chapters, we've got, let's see, if statements. Right? We started with lists. We went to if statements, if, then, and then elif, and then else being our default operator. Then we worked a little bit about while loops. No, we're about to do while loops and user input. I can't remember if the last video had user input or not, but that's where we'll start. Oftentimes in your code, we will find that we have to accept input from a user. And the way that we do that is we set a variable, we'll say name. Oops. Let me actually click on the editor here. So we'll have a variable name is equal to. Now, before we would just enter in name is equal to John here. But you can actually use an input function, input. And inside these parentheses, we have a prompt. You don't have to have a prompt, but it's good to always put that in. A prompt is something that's displayed out to the user that prompts them for a response. So, what is your name? I always like to leave a little bit of white space right at the end, just because whenever the code executes, it's going to, if you don't put that little white space, it's just going to put their name right next to the question mark, and it makes it a little bit more difficult to read. When we develop our menu-driven system a little bit later tonight, that's going to be really important just for simplicity. So, and then we'll do a classic print statement, hello name. We're going to turn this into an F string, a formatted string, where it's going to take the variable input name and it's going to insert it into our print statement. I'm going to put a breakpoint here so we can see as it goes through. Clicking execute. While I was at work this week, I found out how to get dark mode on my local IDE that we use. And before it was like really bright. And I shared that with a coworker of mine. Shout out to Mike if you're watching this. That'd be pretty cool to talk about it. And I got to share it with him. It was a patch that came through our system that was in around November, and nobody knew. So when I was going through, I was like, there's got to be a way to do it. And that is something that's in software development that you, the listener, can actually take into place, into habit. If there is something that you think there's got to be a way to do X, Y, and Z, then just Google it, look it up, get your hands dirty, go and find it, because odds are the thought that you're having isn't something that other people haven't had. There's got to be a way. If you think there must be a simpler way to solve whatever the issue is, go and find it, because odds are it's out there. I just happen to be lucky and now I get white mode or dark mode for my job. So, what is your name? I will type in Andrew. I don't know if I told our class what the whole deal behind Andrew is. So notice how it's there. There's a white space here. That's because we put it there. If not, it would have been on the end. So when I click enter, the breakpoint stops the code here, and we can actually go to our local variables here and see that name has accepted the value of Andrew into a string type. So we can continue, and it will then print to the screen, hello, Andrew. Ta-da! User input. And that's input with a prompt, which is really cool. Oftentimes, you will want to prompt the user for that input. I think kind of some extra credit that we did last time is we made a game, a guessing game, and let's make it real quick. We'll call it guessing game, and we'll say the answer. That's not how you spell A-N-S-W-E-R. Good grief. The answer is equal to 14. Make sure you use a numlock. Put some white space. All over the place. This is what happens when I try to not use a mouse. Okay. And then in guess, we're going to make the guess equal to input, parentheses, what is your guess? And then we're going to go into a loop. Now, previously, we talked about for loops in our lesson where we did the lists, where for each item in list, it was a numerical list as part of your homework. For each item in the list, we added that item to itself to get a total sum value for what that list held. There's also a function that lets you do that too. So let me pause on the guessing game real quick, and we'll show that sum function because that is kind of fun. So we'll say numbers because I am super boring. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Forgive the lack of white space. So we could do for item in numbers, but what I want is to print the sum. Oops, let's say total. And we'll say the total is equal to, we'll say the sum of list. Oops, sum of numbers. So it returns the sum of a start value, default 0, plus an iterable of numbers. And now we're going to print total. So we're going to execute. Come on. There we go. Big money, no whammy. And the answer is 45. So there are a lot of built-in functions that allow you to do those sort of things. We used the loop to iterate over it just to show how loops work. But if we wanted a faster answer, this is the way that we would do that. A sum function, which is really helpful if you have to do it in a pinch. It basically takes all that logic and it puts it somewhere else. I want to see if we're able to go into that sum function. I really need to start using my mouse, but I have no extra space. Let me move this over a little bit. Now I have access to the mouse as I scooch down a little bit. No worries. I'm going to put a breakpoint here. I know I'm all over the place tonight, y'all. Thank you for like, comment, subscribe, do all the YouTubey things. All right, so we talked a little bit about these earlier. Step out, step over, step into. Doesn't do what I thought it was going to do. I thought we were going to be able to see what the inside of sum looked like, but that was not the case. Nevertheless, that was sum. You just have to take my word for it. Get you some. All right, that was dumb. So, guessing game. I promise we'll get into a menu-driven system later. Guessing game first. So, there's another type of loop. We tried the for loop, or item in whatever, right? This is going to be called a while loop. And this is the general format for a while loop. While whatever the condition is still true, do whatever's on the inside. Remember, indentation is important when it comes to Python as a programming language because it needs to know what to do inside of that loop. Now, pay attention real quick to this. There is this little down arrow here. And let's say we put I cannot spell. So we put all these things down here. Notice how the bar here extends down. This is really cool. When you're developing code, oftentimes you can get really long lists and lines of code. You can click this little arrow here and it will consolidate it. There's some hotkey shortcuts later that I'll show you whenever we have a really long list of code and we want to just condense it all down to what each of the individual functions are. But for now, this is good enough. This little side arrow hides what's inside. So while the condition is true, and again, from last time, pass is a placeholder that allows the code to still execute. So we're going to leave that here. So while the guess does not equal answer, remember from, I can't remember how many lessons ago it was, we talked about our Boolean logic, our comparative logic. This, we had double equals, which is comparing equality if one is equal to another. All of you already know about less than, or less than and equal to, greater than, yada yada. But this is not equals. You can't use a single equal sign to check. Like if we wanted to see if it was just equal to the answer, we can't do it like this because that is assignment. Just like here, we're assigning the value of 14 to the variable answer. It's an assignment. So if we put this here, it will ring true every time. It's going to assign answer to guess. No matter what they are up here, it'll just say that that's what the case is, and that'll move forward. Again, remember the problem with computers is that they will often do exactly what you tell them. The problem is they'll do exactly what you tell them, just like my children sometimes. All right, so we're doing the exclamation point, or the bang, is the symbol for not. So while the guess does not equal the answer, we're going to get a new guess, right? Oh. We're going to say guess again, period. We're going to make this a little bit easier as a guessing game because I don't want them to, what is your guess? Instead, we'll say pick a number from 1 to 20. Okay, and if they don't guess correctly, then we'll say guess again. And we're just going to execute this. I'm going to pull it over and show you. This is fun for you to show some of your loved ones. They'll only be able to see the black screen whenever you pull it up. You can hide your actual code so they don't know what the answer is. Let's say I guess 5. Guess again. 9. Guess again. 4, 2. We'll say the actual answer. Wait a second. Oh no. We didn't put a breakpoint. We created what's called an infinite loop. Even if the answer is equal to guess, while the guess does not equal the answer, we're going to print out guess again. Then it should stop if the answer is correct, right? Guess. Oh. Go ahead.
We didn't give it an alternative. Like,
Nope.
we got it set where if it's not, we didn't tell it what to do if it is.
Now, the thing is, it's the wrong data type. I'll show you. Let me pull it open again. So we'll say 14. Notice down here, the answer is the value integer, the number 14. That's the answer. But the input automatically defaults to give us a string. See the quotes? It's a string. So even though the numeric values are technically correct, the computer reads these as two completely separate types of variables. There's a string and an integer. And it knows that you can't have a string and an integer. They're not going to be the same thing. That could be 47 billion or L4. It could be anything, but it's not going to ever give us the right answer. So what we have to do is we have to do something called casting this to an integer. So we surround this input with the variable int, that's short for integer. It's a class. And it converts whatever's on the inside, whatever it gives us, which we know gives us a string of those digits, to a numeric value of int. So now when we run it, I'm going to show it the incorrect value first. So that makes a comparison. They're ints. And then we step through. So now it's asking us to guess again. It's expecting on the input. We're going to put the correct answer now. Oh, we didn't do the integer transformation down here. Tricky, tricky, tricky. We're going to do that same thing here. I'm trying to go too fast, which is why I'm messing up. I'm going to remove. Here we go. All right, pick a number from 1 to 20. We'll say 5. Guess again. Now we say 14. And that's it. It's the end of the program. We didn't tell it to do something after. We could say print you win. Stop it. There we go. Print you win. Now, I do like to do some additional fun things to make the game a little bit more fun. We can have a counter. We're going to initialize it to 0. 0. Okay. And then we're going to add 1 to the counter every time we have a guess. And then we're going to print out however many guesses it took. So we'll say counter is equal to, 1 equal sign is necessary because of the assignment value. I showed you this before, but there's a shortcut way to condense that down. So this and the following are going to be the equivalent. Plus equals 1. So it just increments it 1. You can actually do minus equal if you ever had the necessary, like a countdown, but we'll do plus equals. So these two things are the same. I'll show how that works here in just a second. So then we'll say, guess again. We're going to turn this into an F string. Yeah. Counter attempts so far. Guess again. We'll put it into an F string or formatted string. So what it's going to do is it's going to take the value counter, which is automatically starting at 0. It's going to be 1 unless the first time that they guess is correct. So we're going to say the default value is at least 1. I hope that made sense. All right. And the reason why we default it to 1 is so that if for whatever magical reason, statistically, they guess correctly the first time, it will skip what's on the inside of the while loop because it's not true. And then it's going to print out the attempts. All right. We're going to run it. Let's run it. Pick a number from 1 to 20. We'll say 5. 2 attempts so far. See, that's not correct, is it? How do we fix that? Because we've only guessed once, we need to put the iterator after the next input. That'll do, pig. That'll do. So that when it prints out the attempts, it'll do it before the next increment. Make sense? So when we say 5, it'll say 1 attempt so far. Guess again. And that way, if they're correct, it's going to skip what's on the inside. They'll have 2 guesses and it will be correct, which is what we're going to see now. 2 attempts. You win. Not bad, huh? And if you wanted, you can add in additional logic. You can say, give them so many different chances. So we can have a multi-conditioned here. I'm going to surround the first with parentheses like we've done before. And then we'll say or. So while guess does not equal answer, or the counter is, so as long as this condition is true, we're going to say as long as the counter is less than 5. Does that feel fair? So if the counter is equal to 5, that means they've guessed too many times. And we'll put another condition here. If counter is equal to 5, print you lose. We'll make it a formatted string again. There we go. so many attempts, you lose. We're going to purposely lose. So that's if, and then we'll do else. Oops. Come on. All right, if the counter is equal to 5, because if we're here, we're out of the while loop. Something has happened. Either they've won or they've lost. That's the only way they get to this point. We check the losing condition, which is they guessed too many times. If the losing condition is true, then we print you lose. Else, that means they've won, you win. Speaking of losing conditions, we'll say wind is equal to false. What is it? Capital F. There we go. So instead of if counter is equal to 5, I'm getting ahead of myself. I'm just going to comment that out using our little block. We're going to lose on purpose. We know the answer is 14, so I'm going to put in a 1. A 1 again. A 1. 3 attempts. Yes. 1. 1. 1. 1. This is not good. It's just going to keep on going. But if I put 14, 23 attempts, you win. It completely broke, which is great. You will learn so much more by just breaking stuff than you will by getting it right every single time. I say in my professional development world, I debug 60 to 70% of the time. I only write code a small percentage, and I debug quite a bit because something goes wrong. That's why it's also good to do testing in increments. After you develop a little bit, you test it and then see what broke. So I'm going to close that. We're going to find out what happened. So we know that the counter works. We know that the guessing works. We know that the true statement works. So it must be, it's this or. So the way it works is, like when we first explained the Boolean logic, the and, or, and not gates. If I'm hungry or I'm thirsty, I will get either of food or beverage. Yeah, that's what we're going to go with. So one of those two conditions must be true. I know I surrounded the first one with parentheses. You don't have to. It's just making it a little bit easier to understand. So if guess the answer is not true, then it will continue to try and get the answer. Or the counter is less than 5, it will try and get it. So if the counter is less than 5 and I still get the answer right, it's going to continue. So watch what happens the very first time I try and answer. On our first guess, come on, and pull it over. There we go. So if I put 14 in now, it should stop, but it won't because the counter is still less than 5. And because one of those two conditions is still true, it's going to continue through as if everything is fine. What we need is for both conditions to be false, right? No, let me think about it. This cannot be true. So if this is false, we get it, unless this is also false. Because if they're both false, then we have an answer, or it's less than 5. And so if the answer is not correct, continue to do it. Only if their guesses are still less than 5. If one of those two things is different, or if one of those two things returns true, if it is correct, or I guess in this case, if they return false, that's why this part is really tricky, the Boolean logic. If their answer is correct, or the counter is more than 5, then we go into lines 10, 11, 12. So we'll do and instead of or, because or was breaking it. So now we're going to do, keeps on wanting to hug the other image. So we do the 14, 1 attempts, you win. Now we're going to purposely lose. That was our win test. Now we're going to try a lose test. Say 5, 5, 5, 5, 5. 5 attempts, you lose. Oh, the formatting is a little weird. So it looks like the it's kind of skewed. We'll get into that later as far as what the actual viewing looks like. But we guessed 5 times. We saw all our guesses. The answer is 5. Well, so here's our simple guessing game with some logic using ands, a while loop. So while those conditions are true, so if one of them is false, it breaks out. If the counter is equal to 5, that's our win condition. Ah, that's where we were, win condition. I knew if I said it out loud, I would figure it out. So win equals false. Win, if it's here, win is equal to false. Here's what we'll do. If guess is equal to answer, win is equal to true. So now, come on. Why does it not like that? That's an expression. There we go. What we're doing is we're swapping these around. Yeah, it doesn't like not win. Come on. Okay. So if win is true, which only happens if the guess is equal to the answer, it's going to print you win. Else, because win is a Boolean, true, false. Starts off as false. It defaults to false. So we're going to win. What? Oh no. I goofed up again. This is great. Win didn't have the chance to go to that because it didn't get inside the loop. We guessed correctly on the first try. That's better. So what this is going to do is it sets the answer, gets the first input, initializes the counter and the win condition. Then it checks if the win condition is true. What just happened? Better. Sorry, that was very confusing. Did you hear that? I don't know what that was. Okay, this is also important. Good example on why white space in your code is really important. We got a boogie, man. I've spent a lot of time on this. So, if guess is equal to the answer, win is true. You get the first guess, right? And we can even do some code comments here. Checks first guess. Then while the guess is still not true, or the counter is still less than 5, it'll get another guess, and then it's going to check if that guess is true. And if it is, it sets the true condition so that this, be careful your drag and drop, checks it. I would like to take the time and step through this code, but that can be part 1 of the homework. Duplicate what we have here and step through and try and understand what changes in the variables, the local variables, as things change. So we're going to set the first one is equal to true. You win. Definitely spend some time on this because honestly, you will not learn how to program by watching me. 5 attempts you lose, because that win condition was never true. It printed here when it broke out. Ta-da! It's almost elegant. I like it. All right, now we're going to start on our coffee shop, which is really cool. We're going to keep it very simple in the beginning. We're going to work on. Yes, we were done. It's okay. I deleted stuff off screen. So, our coffee shop. We're going to start with some pseudocode. What do we want the coffee shop to do? For all of my projects, I like to put this kind of a descriptor. This program simulates a coffee shop using a menu-driven system. Takes input from a user and displays options from the viewpoint of a, we'll call them clerks, barista, whatever you like. So from that, what I'm going to do now is I'm going to show you what pseudocode looks like. Pseudocode is basically the English version of what you want your program to do, broken down into segments or chunks. So things like display name of shop. Then from there, I want to show a menu of options. And I put parentheses. What are some of these options? Some of these options are new sale. They can be check current day sales. And we'll try and keep it simple. Close shop. Right? We have a new sale, checking the current day sales, and a close shop option. So then, if new sale, then I want to give more options for, we'll say, coffee or cookies. If coffee, what size? We'll do small, medium, large. Small, medium, large. If cookie, what kind? Chocolate chip. Or what's your favorite kind of cookie? Oat. That might be how you spell raisin. Okay. Then, whatever they choose, we want to display the total. While displaying the total, we want to add sales to total sales for the day. And then we want to subtract inventory. Did we say inventory? No. New sale, current day sales, close shop. Inventory comes later. Later, you want to reduce the amount of cups that you have on hand by one so that that coffee shop knows how many cups to order later, how many cookies to bake, that kind of thing. But all we're doing right now is just, we're going to create a new sale. We're going to pretend we have unlimited inventory. We're going to present the prices. The customer will make their payment method. We don't have to program a payment method in here yet because it's not a real coffee shop. I'm sorry, no cookies. And all we have is cookies. And we only have 3 sizes of plain, regular coffee. What a lot of people like to do is they like to add in different food items. They like to add in different types of coffee, different prices for those types of coffee. You can consult your local, $5 or whatever, and then from there. And then that's the if new sale option. Got it? I love fussing at my code. Isn't that hilarious? This is also kind of fun. If you hit tab, it goes over one. If you hit shift tab, it goes back. This is cool for whenever you're trying to do entire sections of code. Shifting it over. Remember, indentation is important, so using that technique will help maybe in the future. I used it a couple times today at work. I had to put things inside a nested something else. So, if the new sale, we're done the new sale stuff. Go back. The second option, if check current day sales, we really just need to display totals. I guess total dollars. Eventually, you can add extra things in like display how many cups of coffee were sold, how many cookies and what type of cookies were sold. All of that can be tracked with an inventory system you can overlay on top. We're trying to keep it as simple as we can right now. We're just going to show how many dollars worth of sales were made today. And then the third option, we said close shop. We're just going to exit program. Now, eventually, close shop is going to do cool things like remember how much inventory we have left, how much our total sales are, and how much we did for that day. We're going to do that with file handling, which is going to be really cool. We're going to be able to save a document to our hard drive, to your computer. So even after you close Visual Studios, even after the program exits, press any button to exit the program, even after it stops, we'll be able to remember those things by loading in the previous day's information, running our day's transactions, and then saving that information to a file later. Not yet. Stay with me. We're going to get there. Not tonight. But that's close shop. It just exits the program right now. We're going to say it's like a pop-up stand, whatever. And this is the pseudocode. This is what we want our program to do. Have we missed anything? I don't think so. We displayed the name, which is kind of fun. In my program, I created like a user input validation with an employee number and a name. You don't have to do all that. But you can do all of this with things we've already covered in class. We have discussed a while loop, which is how you would surround it all, right? You would say while the close shop button hasn't been pushed, the program keeps running. Even if a new sale has been made, it remembers how much sale it is. Even if the check current status is done, it's ready for the next sale. If the store isn't closed while the store is open, if you will, we haven't clicked the close shop button, it stays running. Just like your computer. Everything that you're looking at right now runs on a while loop, right? While the shutdown button hasn't been clicked on your Windows device, or heaven help us if you use a Mac. No offense. I personally am not. I'm a big fan of doctors. I'm going to edit out most of this, I think. Maybe not. So while that closed or shutdown button hasn't been hit, it will continue to get the next input. Did you have a question? Okay. So we know that we're going to surround it in a while loop. We're going to build it. We're going to use user inputs to collect the items. So a little bit more pseudocode. Now that we know kind of what we want the shop to do, we need to tell it sort of how to do it. We have a general format. That's why I indented these if statements so that we can kind of look at what it looks like. So we know that it's going to be a while loop. We also need some static, constant variables. So we're going to have a small coffee. We'll say it's equal to $27. I'm just kidding. $2. Then we'll have another medium coffee is equal to $3.50. And then we'll say a large coffee, say is equal to $5. And later we'll show a dictionary on how we can associate each of these with particular ounces of coffee. So we can get all the way down to like how many beans we're going to have to do. Bean counting. Notice how my variable here kind of looks a little funny. I have small, all lowercase, and then I have a capital C for coffee. This is called camel case. Small coffee vanilla, But you can look at it and you can see that there are three distinct words: small, coffee, vanilla. Whereas if I were to use a lowercase c there, and I were to just kind of glance at it, it makes it a little bit harder to read as a human. Um, so there's a thing called camel case where the first letter of the next word is capitalized after the first one. So, if you have to have a really long variable name, sometimes people use underscores. That way it looks like there's some white space in between. You can do that, that's fine. I prefer camel case. I don't know if that's because of my C++ starting. Shout out to Dr. Tom Rischel. But that is a way. So we can do that. We have our variables. And then we'll do the same thing for cookies. We'll put an abstract price on it. We'll say $2 for each of the different kinds of cookies. That was gross. And then we will have our total sales. So we're going to need a tracker, just like we did with our counter earlier. We're going to have total sales. We're going to start off with 0, right? It's equal to 0. Because as the program runs, we're going to add these things into it. I'm going to comment these things out. So we have our iterations. Not iterations. We have our variables. These are the only things that we're selling, right? We're selling coffee and cookies. Right? I don't have cookies made yet. You can make that at home. And then we've got our sales, which we will display whenever we say if check their current sales, and then exit the shop if it's done. So I'm going to show you a little bit of formatting. Taking a user input, that's the thing. Input, we'll call it a choice, is equal to input. Enter your selection, semicolon space. So we need a menu. And we need to prompt them for things. We need to say, if instead of new sale, current day sales, and closed shop, we'll say 1, 2, and 3. So 1, 2, 3. And this is a block of text. 3 parentheses, some white space in the middle, 3 more parentheses. Choice 1, this is so bad, is equal to, what was it, new sale. Choice 2 is equal to total sales. Choice 3 is equal to exit. We're going to save this as a variable menu. It looks a little weird, don't be afraid. And you might want to tweak kind of the formatting, how it looks. Print the menu. And then we're going to get another selection. So it just doesn't print infinite menus. So we're going to print the menu. Right, we'll see what happens. It should stop whenever it's ready for us to enter a choice.
So say that one more time about infinite menus. So what are we going to do?
Sure. Well, it's in a while loop. While is defaulted to true. If we didn't have this, it should print the menu over and over and over. But it didn't print. It's having me enter a selection. Ah, how weird. Oh, I got confused for a second. It said enter my selection. Up here on line 22, it expected that first selection. And then it printed out the menu. And then it's asking me to enter selection again. So I'll enter in 3. Enter selection. 4. Enter selection. So we're going to say, oops, we're going to create another variable. We'll say open is equal to true. Real quick, I'm pressed on time. So I'll open. So we'll say if choice is equal to 3. The reason we put it in quotes is because it defaults that input as a string. Then we'll say, so if choice is equal to 3, then open is equal to false. Open is a keyword we can't use, so we'll say is open. Notice the camel case. Okay. Take as much white space as you need. Come on. It's free. I think I goofed up there. To review, we have our variables. We have an is open, then we have a choice. You have a choice. What coffee do you want? We have a menu. It's very basic. I'll show you how to make it pretty later. But for now, we have our menu. It's just a print statement, a string. This string happens to have extra spaces in it. We get a choice from the user, and while is open, doing all kinds of stuff here. All right. I promise you can go back and look at the video here in a minute. So we're going to get the first input. 34 and 35 are weird. I'm trying to get the first input without actually going into the while loop. That's bad design. Don't do that. I just want to show you how it works. So we'll say 1. All right. Enter your selection. We'll say new sale. Why is it not showing me my... Oh, I didn't have numlock. It was thinking I was hitting the end button, which is an acceptable input, but that's why it didn't show a character, because there's no character for end. So 1, 2, 3. Notice how when it hit 3, this changed to false, while false, then stop. As long as we don't hit 3 on this menu, okay, it will continue to run. Your homework is to create another menu for each, well, really just for the new purchase option. You're going to create something very similar to what we did on between lines 26 and 31 for cups of coffee. And then you'll do another one for the types of cookies. You can even have the name of the cookie, the selection number, the name of the cookie, and the price. Selection number, name of the coffee, the price. And then you're going to create an if statement to determine which of the selections were picked, which of the coffees were picked, however many, right? You can use all of these inputs to ask your user what they want. You're going to put it all within this while loop. And then you're going to make sure that when the choice is equal to 3 on the first menu, so we can say, I don't know, title menu or main menu. Right? This is your first more challenging of homeworks because it requires putting together a lot of the things that we've covered in class. But it's very important. Again, with all of programming, it's taking a big problem and breaking it down into individual components. So the first thing you want to do is make your variables, then you start the overall while loop, and then you zoom in. What does the coffee option look like? If they hit 1, we have an option for 3. But what if the choice is equal to 1? Then you have a whole nother loop. You print out the new menu, you get the new input, Then you have your total variable get changed. You're going to want another variable that keeps track of how much this one customer has to pay, right? We have a total sales variable up here, but we need another one that has current sale variable, starts at 0, increments in price for each of the items that they add to their cart. And then after you're done entering the items, you cash them out. It takes that money, adds it into the total, and then goes back to the main menu. Got it? Using this while loop. For those of you who don't have my number, check your email. You should have it. If you're watching this at a later time and you have questions, comment down below. And as always, thank you for attending your regular scheduled program.